Also, most of you may not uh, know the basics of engineering drawing. So this is a preliminary course that every engineer has to go through. And by the way, since I am from Malaysia, I'm from Singapore. I don't really speak Arabic that fluent. I don't actually I don't know Arabic. So please bear with me. I know some of you might come from villages and far away from Jeddah. So if you find some difficulty in my uh, lecture, just do let me know so that I will try to explain you slowly in a much what do you call it easier English so that everyone will understand the concepts or the course by and large, hopefully. So anybody has some problem in learning or in hearing or understanding English here? Anyone, please? Those who knows only Arabic, you cannot communicate in English. Anybody else here? Please raise your hand. In that case, maybe I don't know. Hopefully, you can manage with me. Uh, I will try to speak in. Yeah, who is this? Can you speak out, please? No problem. You have a mic with you? Who is this? Whoever it is, if you want to say something, it's fine. All right, no problem. Yeah, because this is a very what do you call it? A long session, so sometimes it might be uh, difficult for you. No, I have. Who is this? What's your problem? You don't understand English? Uh, who is this? No, I have. Everyone, no, I think. So I think everyone knows English somehow, and I'm trying to speak in a very very slow what do you call it manner so that everyone will understand uh, our lecture. All right. So please feel free. I'm here to help everyone to get a pass at least from this subject because this subject uh, could be a little difficult to you guys because since you have no basic understanding about engineering as a whole. Okay, you can speak to me, no problem. Okay, yes, this subject needs what do you call it? He said, does this subject requires drawing skills? Absolutely not. Don't worry at all. You're not going to draw a picture or anything. We are just going to draw lines, curves by using certain instruments. You don't need to draw like what the cartoon or nothing else like that. Remember, we are engineers and we are trained engineers. So we are trying to make out uh, to draw the basic ideas in a rough way. And now we are using the computer software so that all your ideas can be easily made by a computer. But unfortunately, this is a very basic course, so you don't need to use the computer here. We are not going to use any software. Maybe the last chapter, I will be using one particular software. Otherwise, this is simply like mathematics, trigonometry, or something what you did in your secondary school, where you draw lines, curves, square, circle, rectangle. That's very simple. So don't worry at all about whether you have to draw something like you should be an artist. No, 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 not at all. We are simply engineers and we are doing certain professional work with the use of computers, by the way, no problem. Okay, but there's a but. Of course, you have to draw in this subject. So, in order to get marks, so how you are going to draw? Correct? You are not going to draw manually by using your hand. There are certain instruments available, and of course, you should buy. So that's why today's class I'm going to finish it a little earlier, because I know most of you did not buy these instruments. Anyone already bought the mini drafter? Anyone? Have you brought a mini drafter, a drafter from your seniors or anyone? No one. Doctor, could you record the lessons so we can see it again? Oh, don't worry. This time I'm not recording. This is just an introduction class. So next class onwards, we will be recording it continuously. Don't worry. I understand. I understand. This class is just an introduction class. Don't worry. We are just introduce each other and to make an understanding between us, because I know you are new to this university. You are new to the engineering, and don't worry, I have plenty of experience, and here I'm trying to help you. Actually, I'm here to help you. All right, and together we will pass. I will make you a pass. At least I will guarantee you. And if you require, you might as well get an A plus. No problems. So there are certain certain requirements that you have to follow so that you will get an A plus. Okay, so I will tell you how to. So before we go to the actual discussion, now there are 23 people here in this class. I think most of you already came here, and please make sure from the next class onwards you must attend the class before 10 minutes, because the blackboard will give you the attendance. I am not giving you the attendance. Do you understand? I am not giving attendance to you. The blackboard mark your entry to the class and it records the time. If you are late by 10 minutes, the blackboard will give you absent, and that absent will go directly to the university, to the department. Okay, so please be careful. Don't later ask me, doctor, I attended the class but I got an absent. It's not me who is going to give attendance to you, but the system, the blackboard system is giving you the attendance. Is that clear? So try to attend the class before 10 minutes. That means if the class is at 5 o'clock in the evening, you must attend the class before 5:10. If you attend at 5:11, then you will be absent not by me, but the system will already give you, it's already give you an absent, and I cannot change it. Do you understand? What I will do, maybe you are a good student and you told me, okay, you have a problem, and maybe you have problem at home, maybe your internet is not working, so there are some problems, by and large. In that case, you have to inform me, you have to send me an email, doctor, I have a problem, and the blackboard already marked me absent, but this is a genuine problem, so please help me. Then I will give you attendance to myself, but even then it's not to the blackboard. Blackboard will already consider you absent. Then dean or the management or our university has to decide. If you have lower attendance, they will decide to bar you or to give you a DN. Do you understand? I am not giving you the attendance, but the system is giving. That's the problem with the online classes. Do you understand? If you are taking the physical classes where I can meet you, where I can see you, of course I will give you attendance, but the system will not. So please make sure from next class onwards, attend the class before 10 minutes. Okay? So why this attendance is very important? Because I am giving certain bonus marks to attendance. Okay? In fact, I'm going to give you 5 marks or 5 grades to your attendance alone. So if you get 100% attendance, those who are attending right from today, if you attend all the classes, I will guarantee you that I will make you a pass. Provided if you get like 55, then I will give you 5 marks only for attendance and I will make sure that you will pass. Do you understand? That's the deal between us. If you attend 100% marks, if you get A, I will give you A plus. If you get B plus, I will give you A. If you get B, I'll give you a B plus 1 grade. If you attend 100% attendance, only for attendance I will give you, because I know engineering is a discipline and engineers need to be disciplined. So we are not Albert Einsteins, we are not great scientists, we are simple human beings, we are trained engineers, but of course we need to be very, very disciplined. You know why? Because you are going to make everything. You are going to construct a building. You are going to design a car. You are going to design a rocket. You are going to design an aircraft. So if you are not a disciplined engineer, then you might make a mistake in the engineering, and probably that will cause somebody to die. Do you understand what I'm trying to say here? So I'm always giving full support and encouragement to those people who are very sincere, who are attending the classes regularly. I will just consider them and I will try to help them to make a pass at least somehow. Do you understand? So let's make it very clear. All must attend the class before 10 minutes of this class. So that make sure that the system, Blackboard, will give you a present. Once you are 100% attendance, don't worry about your marks. Try to get as many as marks, then I will give you one extra grade. That's my word to you. You understand, all of you? Okay, that's our deal now. So, yeah, okay, no problem, no problem. I know, you must be very happy. And there are 24 people here, and the time is now 5:13. So, the Blackboard already gave you attendance, all right? But in order to, know you all, I'm going to call your names now so that I will see how many of you are attending here. Just only for today. The next class, I will take an attendance at 5:10 to myself. You know why? Because sometimes you may be late, and the next day you come and you send me an email, Doctor, I have a problem. So that I will check the attendance previously. So if you are a genuine person, you have never missed your class, then I might give you a present. Do you understand? So every time, not only the Blackboard, me too, I am also taking the attendance. Okay, just to help you. In case even the Blackboard give you an absent, I will consider it and I will give you a present, so that I will not reduce the grades. Do you understand? So there are two types of system here. One is the Blackboard, that system is giving you attendance. Other one is myself, I'm taking the attendance, just to make sure that those good students who are very good but have some genuine problems, I still can help you, because the system will not consider you. The system, for the system, you are just a student, that's it. But I am a human being, so I can understand your problem. All right. Okay, so let's see the attendance now. How many of you? 24 students here. Let me call your names first, and then let me see how many of you are attending here today. Okay, in my list, I have this is 14, 968. The first name is Anas Khatem Saad Alhamdan. Is he here? Someone can speak or speak. So if you are here, just in the in the chatting, you just, yes, doctor, I am here. Yes, yes, something you say. Okay, that means Anas Hatim Saud Al Hamdan is absent today. So next one, oh, we are here. Okay, Anas is here. All right, Anas is present. Anyway, I will check the what do you call it? The orders also, right? The Blackboard also will give you the attendance. So please be careful. All right, no problem. Muhammad Taha Muhammad Falata here. Muhammad Taha Muhammad Falata. No, I'm not Anas. So who is this? Who is say yes? Muhammad Taha? Sugib. Sugib, don't worry. I will call you. Whenever I call you, say yes or no. Okay? Don't do that. So Anas Khatim Saad is absent. Muhammad Taha Muhammad Falata absent. Abdullah Majid Abdullah Al Quraidi. Abdullah Majid not here. Muhammad Abdul Khalik Abdullah Yahya. Okay, there are two people. That means Abdullah Majid is present, right? Say yes or no to me. Can speak out. Abdullah, you are here? Abdullah Majid. Okay, good. Now, welcome to. So these all are. Now you see. Now you see here. Don't worry about this. This is nothing. Just if you attend the classes, things will be all right. All right. Okay, now let's see what we are going to learn. Do we need a book? Don't. I already sent you a book. How many of you received the check the blackboard? I already gave you all the slides. I gave you a book. Have you checked it? Check the course description. In the course description, I already gave you all the slides and I already gave you a book. So don't worry. You can check the book. I will give you exercises and exam only from the whatever I gave it to you. I will not ask anything away from that. Don't worry at all. You are here to learn. Okay? I'm not going to crush you. I'm not going to kill you. No, no, no. That's not my intention. Okay? I'm trying to help you. So we are trying to learn together. All right? Provided you attend the classes and sincerely, you should be very sincere in doing that. Absolutely, you are fine. Okay, don't worry. Okay, the course description. Now, somebody asked me what you're going to learn from this class, right? So now this is what you're going to learn. Skills of freehand sketching, first of all. So it's just a freehand sketch, okay, for something. Initially, of course, initially you have to do some freehand sketches. Then there is a what you call projection. Later we'll see what is projection. Orthographic, isometric, dimensioning, views, prediction, what do you call it, prediction, primary, successive, auxiliary views, development of surface, sectioning, introduction to assembly drawing, understanding of standards, conventions, computer graphics, use it SolidWorks. This is going to be only one class, so don't worry about the software now. And this is the last class. But the rest, all you are going to do manually. Manually, you take paper, use your mini drafter, and draw it on your own by using pencil. And once you finish your drawing, take a picture and upload it to the blackboard. That's it, your job is done. Once you do within the time, you are fine, you are good, you will get full marks. If you cannot finish it within the time, maybe you should ask me, so I'll give another 1 or 2 hours extra so that you can submit again, but you will be losing some marks in that way. Okay, I always give plenty of time. I will give one full day, 24 hours I will give you. Sometimes 48 hours I will give you. You take 2 days, no problem. Finish it and submit it. Is that clear? Don't worry. Okay, I'm not going to ask you immediately. Maybe for the exam, in that case, for the quiz, for the midterm exam, you have to finish the exercises within the time. Let's say maximum 3 hours. Otherwise, all your assignments, your homework, you can take 1 day or 2 days, no problem. Do you understand? Do we need to use a program in this? No, not at all. Here, you are not going to learn any computer program. Nothing, nothing. Just feel free. Here, you are going to learn the basics, how how this computer program is working. Okay, because anybody can use a computer, as you know. Even a secondary school boys, now they are very good in computer than us. They are very good. All right. So this is not here to learn the computer, but we are learning how the computer makes the drawing. Do you understand? What are the calculations? What are the assumptions? What are the concepts in making the drawings? So once you know the concepts, the computer will do that, so that you can check whether the computer does is correct or not. So you are doing only on paper. Yes, you are doing only on paper, and based on the paperwork, you will be given grades. Is that clear? Good. Now, the learning objectives, if you see, to learn the principles of graphics, or the quizzes, objectives, subjective. No, no quizzes or objectives or anything. Only drawings. So there is absolutely no exam to ask you to read and write. No, no, not at all. Your job is to draw. This is an engineering drawing class, and you are going to discuss with me through drawings only. You remember, drawing is our language. All right. So you don't need to study or read anything on this. Yeah, every week there will be at least 1 or 2 drawings. From at least not now, maybe after 2 weeks time, 2 or 3 weeks. Then every day, every class, you have to draw. It's all about drawings. Yes, it's all about drawings. Yes, yes. Good. Um, uh, nice a week. Yeah, once in a week, I'll say. Once in a week. Yeah, yeah, right, right. Yeah. Once in a week in this class. When you start the class, for the first 1 hour, I will take some lecture. I'll give you some lecture. The next 2 hours, you draw at your home at your own convenience, and then you submit it online. Okay. No, no. Now there's no need for any WhatsApp group. Don't worry. Okay. We will see. We'll see. We will try to use the blackboard as much as possible. Okay. Because if we start a WhatsApp group, probably I cannot sleep or you cannot sleep. Both we will be having problems. Okay. So we'll see what we can do that. Don't worry. Then the next task is to develop students' visualization, imagination, and ability to represent the shape, size, specifications of physical objects. Objects. Then visualization is very important. We'll see how later. The third one is to enable the students with various concepts like dimensioning, conventions, and standards. So don't worry about this. Dimensioning is very, very easy. Later we'll see how it works. Just now I am giving you an introduction because only 27 people today. Anybody late? Whoever late today, you are already absent. Do you understand? Blackboard already gave you absent. If you are late more than 10 minutes, the blackboard will give you absent. So careful. Somebody is now just now attended. Who is this guy? Who just now attended? 27. Anyway, whatever it is. Okay, I cannot help you, but you just put your number in the chat. I will give you a present to me, but not the blackboard. Since you attended today, it's good. Okay, okay, okay. I will give you attendance, but the blackboard will give you absence. So don't worry. All right. So the department will think that you are absent, but I consider you as present today, but not in the next week. Next week class, I will not give you any present once you are late more than 10 minutes. All right. Today I will give you, okay, because you don't know. Today, whoever attend today, I will give you a present. Good, good, no problem. All right. So we were in the other room. No problem, no problem. But try to come to the class before 10 minutes, so otherwise you'll be in trouble. It's not me, but the blackboard. If blackboard says zero means zero. That's it. So the university will give you DN right away. Yeah, I cannot even say please give. This is a good student, my favorite student. Give him a pass. They won't. They will give you DN. Careful. All right. Now the last one is to able the students to draw standard 2D drawings. Yes. So we will meet in the main room, whatever it is. 2D orthographic projection, don't worry now, you feel like orthographic, these are very simple. Later you will learn it, okay? So these are the main objectives of this particular course. So as somebody mentioned here, you are going to draw, and draw. You're not going to read, you're not going to, write an exam, you have to write an objective questions. No, not at all. Here only you have to draw something and then you will get the grades. All the drawings online. No, you draw at your home, take a scanned picture of it, cam scanner, and send me or submit to the blackboard. So I will check the blackboard. If you have submitted within the time, then I will give you marks right away in the blackboard itself. Okay, so you will get to know your marks right away. Is that clear? Right, good. All right. So I hope there is no doubts until now. It's not very big deal. 29. There's one guy joined now. Okay. Right. So, uh, right. Now you see here fundamentals, concepts, and principles of projection. Okay. Knowledge is fine. Uh, because you are going to learn some knowledge, get some knowledge on the concepts and projections. And what are the skills you are going to learn? This is very important for the engineers. You are going to use or applying your basic engineering graphic skills to draw 2D and 3D part drawings. What is 2D? What is 3D? Later we'll see. All must have known like what is 2 dimension and 3 dimensions, right? So let me see. If this is a square, this is a 2 dimension, right? Length and breadth, correct or not? But if I draw like this, then now this is 3 dimension. because length, breadth, and width also. So only this is two dimensions where you have only two dimensions, and if you add another dimension, that is three dimensions. So you are going to learn both of this. So that is what it says. This is a three-dimensional view, and only this shaded area is the two-dimensional drawing. So this is what you are going to do, not like a simple figure, maybe some difficult figures, a little difficult figures. Okay, all right. Then now you see the competence that you will know. So now here are the course content: projection, orthographic projection 6 hours, isometric 6 hours, meshing view 6 hours, 2D sketch 4 hours, computer aided design SolidWorks for 4 hours, assembly drawing 4 hours. So totally it is 30 contact hours. You'll get 33 credits. Okay, now these are the probable exercises you're going to do. The first one is um, utilization of the necessary drawing tool. This is what I just now told you. You go and buy the drafter, the pencil. Then, in order to make circles, you need a divider, protractor. Then all those stuff, you whatever you need, you have to buy it. So how to use it is what we are going to learn for the next class. How you are going to use it. So it is better you buy it before the next class. It will be much better, or at least try to buy it within 2 weeks time. It is better if you come with an instrument next week. It will be much better. Okay, so you will learn right away. So please try, all of you, to buy one. Call Jerry today immediately and try to find your own drafter. Okay, then skills for freehand sketching, methods of projection, third view, auxiliary view, development of surfaces, sectioning, assembly drawings, standards and conventions of drawings. Then, of course, computer aided graphics, CAD. No, don't worry. If you tell the guy in the shop, he will give you everything. Okay? You tell him you need a set, so they will give you all. It's not going to be very expensive, around maybe 100 or 150 real, not more than that. And some lower quality drafters also available, maybe less than 100, but don't buy it. That will not give you a very good grades, because if you make mistakes within the time, you cannot draw. So buy a good quality one. Speak to the Jarir or any other companies and ask them which is the best one so that you can use it. Okay, you can give it to your brother maybe. Wait. I will tell you. Don't worry. We are just introduction. All right, knowledge, skills, and so on. Okay, now this is most the most important part for your grades. Okay, this is very important. All of you are worried about your grades now, so let's see how we can get grades. Homework and assignment, 10 grades. Quizzes, 10 grades. Midterm exam, 20 grades. Oral presentation, 5. Individual laboratory report, 20%. Midterm exam, 20. Then finally, attendance 5%, student portfolio 5%. Don't worry. I'm going to write it here. So very simple. I will put this way. The exercises every week you are doing it is total 40. Okay. The homework, assignment, quiz, exercises, everything together 40 grades. Clear? Then 20 grades is for the midterm exam. So the midterm exam is just a 3 hour exam. You do it there, you get 20 uh, grades. So the midterm exam will be on one day or maybe two classes. So that is 20 grade. And the remaining 40 grade is, it includes the final exam, the student portfolio, attendance, and laboratory, whatever it is. Okay. So this 40 marks include your attendance, your student portfolio. So I'm not going to tell you now how much I'm going to give, but usually it is your attendance get 5 grades. Okay, and then laboratory, whatever they say laboratory, these are standard, but this laboratory marks also will be coming under the uh, this assignment exercises, laboratory, quiz exercise, everything is this 40. These two are exams. Okay, and in this 40, probably 5 marks, 5% is for your attendance, and maybe another 5% is for the portfolio. Okay, so this is how your grades will be. So now you may be wondering how you're going to, so how you're going to achieve this. Okay, so the first thing, attend all the classes. Correct? Attend. If you attend all the classes, you will get to uh, this 5 plus 5, right? So this 5 will not be given now, but this 5 is entirely only for your attendance. Okay, there is no theoretical tests. Okay, no theory at all. This is simply practical. But of course, you should know what it is. I'm not going to ask you questions of what is this, explain, subs. No, not at all. Here you are learning the skill, and in order to make the skill yourself skill, there's some basic idea should be there. So if you know something, you can draw very simple. You don't need to study any theory or in a book or so. All you have to do is use the theory to draw, the views or the engineering shapes. That's the idea. So, okay. Later we'll see. I'll show the book, then you will get to know. Attendance. So final exam is 40%. Then you have midterm exam 20%, and this is how it works. Any questions on this grading? Like I told you earlier, if you attend 100%, I will give you 1 grade. Don't tell anyone. If you get A, I will give you A plus. If you get B, I'll give you B plus. But when you get A plus, I cannot give you anything. So for those guys, of course, if you get 95, I'll give you 99 or 98. That much I can give you. Okay, but those who are attending 100% classes, definitely they will get a credit from me. Okay, it's personal, not official, but it's personal. All right, good. All right, so now there are several books, but I already gave you a book. Yeah, there's one final exam. Absolutely, there's one final exam where you will have to do a complete assembly. So the final exam can be made in 2 classes, 20 plus 20, or 20 plus 10. The remaining 10 will be given to your attendance and all. So somehow, 40, 40, 20. In within this, your attendance, your student portfolio, everything included. You follow me? We'll make it that way. And this 40 marks is like, if I give you 8 drawings, 8 into 5, 8 into 5 is 40. So if I give you 8 exercises, homework, assignment, each drawing will be 5 marks, means 8 into 5, 40, you got it. Okay. If you attend all the classes, 5%, 45. If you attend the midterm 1 day exam, get 20 marks, you get 20. That's it. That way it works. All right. Okay. The textbook. Let me see whether I give you the textbook. Uh, all right. So not much on this. So that's all from the coursework here. Any questions based on the coursework? Now you know what you are going to do and how you are going to get your grades. I hope you now understand it. All right. Any questions? Guys, you can speak. If you have a mic, you can say hi, hello, doctor, salam alaikum, how are you? I'm fine, this and that. You can speak to me. Absolutely no problem. You understand? I'll be very happy to hear from you. If the college is open, if the government allowed us to open, we will be very happy to go to the university. So things will be much easier when we see each other. You can ask me directly so I can draw something for you. It's very easy. But now it's going to be a little difficult, I know. So your email is not found. Okay, don't worry. I will give you an email. But right now, please use the Blackboard. That's much better. Okay, because Blackboard is our platform. All right. So let me see, navigate the slides. Okay, let me show you the first thermodynamics, not this one. Previous slides. Okay, let me see. Is this overview? Okay. All right. Uh, so before we go to the actual, because today I'm not going to keep you for long. I know this is the first class. If I say more many things, you must be worried, and some of you might drop this class. So I'm not going to make you very uncomfortable. One thing I'm telling you very clearly: I'm a design engineer for 20 years. Okay, I was a senior research and development engineer in Singapore. I was designing your laptops. I designed a laptop. I designed two, three printers. So engineering is, when you find it difficult, it is difficult. But when you try to enjoy it, you will enjoy it. Very simple. Okay. So the first thing is, you should not worry about your grades. I told you I will take care of your grades. All I am caring now, how you learn, how much you learn. That's the most important thing. Forget about everything. Okay. Try to learn. You are learning something from here, and how you're going to use it in future. That's very important. Okay. Don't worry about the grades for this particular subject. I will guarantee you. Okay. All right. So now, engineering drawing. Now, all of you here, maybe you might prefer to be an electrical engineer next year, or a mechanical engineer, or a civil engineer, or an industrial engineer. So whatever, you see, there is always something called engineer, engineer, engineer. What is this engineering means? Anyone? What is engineering? Engineering means making. Okay. So making something is what you call engineering, or do something on something. Okay. Creating, oh yeah, creating is also engineering. Of course, he is the best creator. God is the best engineer, you must say. Okay. So nature is also your best engineer. All right. So here the problem is, engineers can be from different discipline. All right. Somebody wants to become an electrical engineer, like I said before. The problem is, designing is part of engineering. Yes, right. Designing is also part of engineering. Designing, drafting. There are several work in this engineering. It's a creative work, and we all are not some all the time we are creative, but we are sometimes using our skill to draw. So you can become a draftsman also. So that's also part of engineering. All right. So what I was saying, uh, an engineer can be from any discipline. And the problem is, the engineers may not know or may not have a common language. Remember, when I was in Singapore, my company is Hewlett Packard. Have you seen HP company, right? All you must have seen HP computers, HP printers, and HP whatever it is. So we are a big company. We are manufacturing almost every electronic or electromechanical devices, except we did not make the cell phone. We unfortunately we missed it. When I was in Malaysia, Samsung was the poorest company. Samsung in fact was a sick company. I went to Samsung once and I saw their Samsung TV, and the people are very sad, and the company is not running that way. But suddenly Samsung become the world leader in cell phones. So that is how it works. HP, we never thought to make a cell phone, and now we have lost. We have lost our market. Although we have capabilities to make a cell phone, we never tried it. And you remember Nokia, the other company who were manufacturing the cell phones. Now they are nowhere because they cannot cope with the technology. When Samsung made the smartphone, the Nokia did not make it. They make the big old cell phones, so they have lost their market. So now you see the difficulty is, yeah, of course, yes, they did not upgrade, they did not update. That's very important. You have to update every day. So now the problem is, just I mentioned, I would like to give you a story. I'm from Singapore. Okay, so my company, my head office, HP head office is in Singapore. Our work is in Malaysia. Our design is in China. Our drafting is in Thailand. Our manufacturing facility is in Indonesia. And of course, our head office is in San Diego, USA. Now, the point now you see here, how many of us engineers are working now? We in Singapore, I never know any other language than English and my own. So, Malaysia, we have the same company. Indonesia, Thailand, China, and of course, US. So, there are six or more than seven type of engineers who have seven types of nationality, seven types of language, seven types of culture. So we are such a, what do you call it, such a chaos. So we don't speak each other. Then how can we make a product? Do you understand what I'm trying to say here? We make an idea design in Singapore, then we give this design to China. So China will do the design or drafting, and they will give the drawings to the Thailand people. So they will make the cover parts. Part of the drawing will be sent to Malaysia, and part of the drawing will be sent to Indonesia. And all these operations are controlled by the United States back in San Diego. So the problem now is, we all engineers have to make the product, but we don't know each other. We don't know how to speak to each other. Do you understand my problem? So if I want to teach you, you are you understand English so fine, but when you speak to a Chinese guy, Chinese has no way they can learn a single English word. They don't understand. Japanese, they don't understand a single English word. And also Indonesians sometimes, Thailand, so. Malaysians, okay, they speak English. So now a group of engineers from different background, how can they make a single, like let's say a laptop or any other mechanical device? So how we can communicate? Any idea? How we can communicate to each other? And remember, we have to make we make a product. Yeah, right. With drawings. Yes, exactly, exactly, exactly. Oh no, 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 not Google Translate. No. If you use Translate, it'll take months to teach him. It'll take months. How can I communicate to you if I don't know your language? I'm trying to show you. Okay, I need a laptop. Can you make a laptop? Then you will ask me what kind of shape, what kind of size, what is the function, what is the material, what is the manufacturing method, what is the cost? How can I do that? So people will die before they understand each other. And how can you teach one guy who doesn't know English? So in order to teach him English, that will take 10 years. Like if I teach English to a Chinese guy, I can never, because he's already 50 or 40 years old. Can you teach him English? No way. He's not ready to learn. So, like one of our friends here said very correctly, engineering drawing is the language of engineers through which we communicate each other. That's why this subject is extremely important to the engineers, because this is our communication language. Do you understand? So, for all of us engineers, irrespective of our nationality, irrespective of our language, irrespective of our religion, we communicate with only one language, that is called engineering drawing. Because anyone, even a small boy, can see a drawing and he can understand. That's the idea of engineering drawing. Okay? So, when I ask anyone, what is your language as an engineer? You say, engineering drawing is my language. Of course, you can speak to anyone, right? If you know to draw something, you draw, and I try to show him. So, when you make a standard shape, and we have a common instructions, common what do you call it, theories or common laws, then everything will be all right. So The topics we are going to cover: graphics language, engineering drawing, projection methods, orthographic projection. Don't worry about it now. Don't worry at all. Drawing standards. So, what is most important is this drawing is the language through graphics. Graphics mean pictures. And you're not going to draw the pictures, by the way. You cannot. So, how we are going to address this issue? So, this is what we are going to learn from this first chapter. And then topics, the traditional drawing tools. This is what you're going to buy. Lettering, freehand sketching, of course, everyone knows. All right. I'm sorry. Okay. Guys, in between, if you find it difficult, maybe we'll give you a break, 5 to 10 minutes, so you can go and take a coffee or something. Okay, just feel free. So how we can for every, or we can say after 1 hour, I'll give you a break for, let's say, 5 to 10 minutes, or 5 minutes rather, because you are at home. So if I allow you to 10 minutes, you go and sleep. So that's not a correct way. So I'll give you 5 minutes so you can go to the kitchen or go to mom and get something to drink and come back, so that you will be relaxed. And for me too, it's very difficult because I'm talking, and now my throat is giving me trouble. Okay, so now I'm giving you 7 minutes break. So we'll meet by 6:10. Let me go to the kitchen and take a coffee or something. Okay, I cannot speak. I have a problem in my it's very difficult because I've been talking to you continuously for 1 hour now. So let me go and take a coffee or something. So those who are online, just be online. We will meet again by 6:10, exactly 7 minutes from now. Okay, thank you very much. Please go and relax for 5 minutes. Okay, take a coffee or something. Okay, we'll be back. Okay, now let's because most of you are asking me how to draw this that. Let's see how. Okay, to start with the the graphics as a language. Let's make it easy way. Uh, as a child, you are always, I'm sure your mom will know, our mothers are our first teachers. So normally what they teach you, they will try to show you something by showing you a picture or giving you a toy, and also by telling you some story. So the best way to communicate is to show some shapes or something like features, size, and all, rather than writing it. Suppose if I ask you, okay, what is a computer? So maybe you have your brother, small brother, little brother, sister. Then I ask your teacher, what is a computer? Then you will find it. You go and tell her, a computer is like this, that, and you try to teach her like one full day. She cannot. But instead, what you do, you simply draw, make a small sketch, or show her a picture. Then she will know, oh, this is the picture, height, very nice. Oh, this is what a computer. But remember, in order to make a picture, you need something there, right? A camera can take only what it sees, correct or not? So before you make anything, how can you show a picture? It's very difficult, right? Because it's not there. You have an idea, it is in your mind, And how you can ask the others to understand that? You cannot show a picture because your mind cannot take a picture of your own. Correct or not? Because it's in your brain. So what you say, what you do, whatever comes to your mind as a picture, you put it in a paper, in a two-dimensional paper, and try to make out what you're trying to show them. We call it as a freehand sketch. That is the preliminary, primitive method of communicating your idea to the other people. Now, why should you communicate your idea to others? Because you cannot make everything on your own. You need people, you need somebody's hand to do the work. So, in order to make a component or not to make something, you need more people to do. So, you need to communicate your idea to more people so that they will understand that, so that you can make things whatever you design, whatever you created, whatever you wanted. So, that's the idea of a graphic language. Try to write a description of the object, test your written description, and try to ask somebody to read it and make a sketch of it. So, when you see in a nutshell, the word languages like what we speak, Arabic, English, all this are inadequate. Very important. Our languages have very inadequate if you try to communicate an idea. All right. So why? Because you need to show them the size, you need to show them the shape, and of course you need to show them the features. Now, what is size? You all know. Size means the dimension. What is your height? What is your weight? What is your, you know, the size? Size everyone knows. Shape also, yes, this is round, this is square, this is rectangle, this is triangle. Yeah. But what is feature? Feature is, suppose this is let's say a circle, right? But you see the circle has a small step here. So when you see from here in this angle, you can see this first circle, second circle, and third circle in the same way, but it is not. When you see from this three dimension only, you see there's a step here. Correct or not? So this is what we call a feature. A feature is change, kind of what do you call it? A feature is what the way how the subject look. Mm, yeah, to some extent you are right. Okay, so what we learn from here, our language, what we speak, is not adequate. Yeah, if it comes with holes, no. Even difficulties. Sometimes if you have a hole inside, you cannot see inside. Then that's a big problem. Like suppose I have a, let's say, I have a like this. So this is, when you see it is a square, right? So but this is like this, right? But the hole is only this side. You have a hole, okay? And this hole is only to this much only. So in this side you don't see it. Do you understand what I'm trying to say here? The hole is only up to the middle only. You cannot see it from here. So if anybody sees from this side, they see no hole. But anybody see from here, they see only a hole. If anybody see from here, no hole. So how can? This is a big problem. You understand? You can't see it from the inside. Of course, you cannot. So that is what they say the features, which is extremely important in the drawing. How you can show the other guy that is something inside which cannot be seen from the outside. So this is a feature. So you can see the shape. Shape is square, and you can see the size, length, and this is the feature there. All right. Okay, so now let's go back to the slides. What is it? Share files and text time. Okay. All right. It goes back. This is a problem. Every time. Share now. takes time. Why it's not working? Let's see. Now we are sharing it. Okay, so we are here. All right. So this is what we see. The features sometimes you could not see it, but still you have to communicate to the people that there is a feature inside. Okay. So now you can see the graphic language is an engineering application to use lines, surfaces, edges, contours. So the language that we are discussing is drawing or drafting. All right. So this drawing can be a freehand, or it can be used by instruments or a computer, of course. So we are here now. We are trying to learn these two. So once you decide your own engineering discipline, suppose if you are a computer engineer, if you are electrical engineer, then you will draw electrical circuits. If you are an electronic engineer, you will draw electronic circuit. If you are a civil engineer, you will draw the structures of a building. If you are a mechanical engineer, you will draw anything like a wheel or a machine or whatever it is. So the computer can be used for individual engineers based on their discipline, whereas all engineers must know these basic two things here. That is what we are learning from this class. Okay. So what does he mean with surface, edge, contour, and lines? Now you see there. We'll see the next slide. See now. The same picture is drawn like this. Now see how difficult it is. That's why somebody asked me, Doctor, should I draw? Should I be an artist? That's of course you're not going to be an artist. All right. And at the same time, there are certain methods to draw this so that anybody can draw. Do you understand? So you don't need to be an artist. You need special training to draw it. Believe me, those days they are. In fact, when I joined my company, there were no computers that time. So we drew everything by using hands. you know. So even the laptops and all this, not laptops, but before that, we made every drawing by hand. Remember how difficult it is. You have to answer your supervisor first, then supervisor has to answer his manager. Manager has to answer the design manager. Design manager has to answer the general manager. So all these people will kill you. Like if you make a mistake somewhere here, like a very small mistake you make it here, then everybody will be after you because if you miss it, this will go to supervisor, manager, general manager, and of course it will go to the top level. So difficult an engineer's job is, particularly design engineer's job is like hell. I'm telling you, many times I was during my time we have problems. So don't worry, we are not doing this difficult drawings now, but just to now the point is, this is what I've shown you just now, right? This is what I've shown you. Remember the previous case. So this is the actual picture, and now I'm showing you the drawing. Correct? So now this is known. Now you know what it is because this is a three-dimensional, like very similar to a picture. So anybody can understand that. But the problem is even this one. So the dashes form for inside. Yeah, exactly, absolutely. Yes, the dash lines are hidden lines. We call it as hidden lines. He got the point actually. So for those who don't understand this, let's go a little slower. No problem. So this is a three-dimensional object, correct? And this three-dimensional object you can see from this side. Okay, how many positions we have to know? Okay, that's a very good question. How many positions you have to know? How many positions generally for any shapes? How many positions normally you have? So now you see here, uh, four, six. Okay, Fine, fine, fine. 6, 3. Okay. Okay. This all your idea, but I have some experience. Okay. You know how many views I made it for a particular component in the printer? Any guess? How many views I made for one particular? 9? No. Any wild guess? You won't believe it when I say I made a drawing for a printer, and for a particular component. You know how many views I made? 120? Very less. I made 675 views. Can you believe it? I made 675 views. Yeah, right, right, right. Wow, yes, 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 yes. Why? But you must be wondering why. You said, as you say, front view, top view, side view, right side view, left side view, front view, back view, top view, and bottom view. Only six, right? But how I made 675 views? Correct? Inside, that's way too much. That difficult. That is that much difficult part. It is. Maybe I'll show you the drawing one day. Just remind me. Probably most of you will drop the class and you will run away. Now, maybe, but after a while, once you finish this class, you may not. But this is how. You know why we need 675? Because the component itself is very complex. It's a big component. There are so many features inside. So we make cut sections here. We make each and every part. So I make a cutting here and show it there. I make a cutting here and show it there. I make a cut here and show it. So that there are so many hidden components inside, or hidden features, so that I will make like 600 or 500 drawings for only one product. This is a very rare. Not all the components will have 675. Absolutely no way. But this is the housing for the entire printer. Okay. So what I'm saying is this is also possible. It's very easy, but don't feel that okay, this money. This will give you an idea how many possible views you can have. The problem is cut section. You can cut it anywhere, and you can make a what do you call it? Now I show you why. How? Okay, let me show you. I have a component like this. Um, this is my component. Can you see it, right? So this is my component. All right. So I can see from here. I'm drawing it from by using a mouse. So see, it's very difficult. So this is a component, right? Now this may be a component. So if I gave a view, so I see it from here. This is the front view, correct? If this is front view, this one is the back view. This is the right side view. This is the left side view, top view, bottom view. So there will be 6 basic views always there. Correct or not? But suppose I have a hole here. Okay, this hole is throughout, and I have another slide and another one, maybe a little longer, something like this. So now if you see this, when I see from here, I cannot see there's a step here and there is 2 extension here. Nothing I can see from here. Correct or not? And also I don't know where the hole is there or not. And this hole, you remember, there's one more hole here from the other side. So they put a screw or nut from the other side. So the part becomes so complex. I cannot show it within 6 views. So I might need another view so that I can cut it here. I can show what is inside. So that's why virtually there is no limit for a drawing to show a standard. Of course, the standard views are there, but there can be hundreds of views possible. That's the idea. Okay. Now let's go back to this condition what we discussed. Like I said before, always there's a front view, then there's a side view, and there's a top view. So there are three basic views, because otherwise you see the front view is the same when you see it from the back. The right side view is almost same when you see the left side. This is for the symmetric shapes. It's always you can use only three basic views. So that is what they show it here. This is the front view when I see it from here. This is the top view of this. Correct or not? Both are two-dimensional views for this component. And of course, this is a three-dimensional view of the same component. Is that understood? So you can show the same component in different ways by showing the entire component like this. That is what we call a projection or isometric views. Or you can make it in a two-dimensional drawings by showing it only the views what you have seen: front view, top view, side view. And these views can be hundreds. As I told you, 600 is possible. You can make any top view, side view, cut section view, right hand side, everywhere you can, whatever you wish, you can cut it and put the drawings there. All right. So this is some give you some idea. Okay. Now I want to yeah, this is the instrumental drawing, the computer drawing, and instrument drawing. Now you see the most important again. Uh, okay. Before that, I just make the shape. And what is the size? Without size, you cannot make anything. So what we have to do, what is the diameter of the circle? What is the length of this tip? What is this depth? What is the length from here to here? What is the total width of this component? Correct or not? This and all I should know. What is the height of this component? Correct or not? So these are the things we should know in order to make this component. So that we have to use it by a concept called dimensioning. So this is what dimensions are about. Instruments are used to draw the straight lines, circle, and curves concisely and accurately. So the drawings are usually made to scale. Scale means by using the scale, you can draw the shape. Now, I might ask you some question. Now you see here, in order to draw this, the length is 38 millimeters. Generally, it is in millimeters. 19 millimeters. Fine, I can draw in a paper. But what if I have to draw a big building? How can you use the paper? Can I use the paper? How will you convert it? How can you convert it? Guys, you understand my question? Plan. Very nice. Very good. Yes. Okay. Good idea. So what I'm asking you, whenever I try to draw any shape, that shape needs to be drawn in a paper, but you cannot draw with the true scale. What I mean is, if you want to draw a building, the building is like 100 meters height, but your paper is just a small paper. So how can you draw the building in a paper? There, what we do, we call it as a scale. Scale means here, if I draw a small rectangle, this is the building. This is the building in our Cornish Road. Let's see. You know the building, right? Cornish Road building. A similar building is there. Remember that? So this building I want to draw in a paper. Then what I do, I just simply draw. This is 100 meters. 100 meters is so high. But I draw it in a paper and I made it like, if that is 100 meters, here I made 100 millimeters. Very simple. That means each of my 1 millimeter represent 1 meter in the original scale. You understand? So that means this is the scale here. If here it is 1 millimeter, then there it is 1 meter. So for 1 meter, how many millimeters? 1 meter is equals to 1000 millimeters. Correct or not? So the scale is 1 is to 1000. Very simple. Correct? So I made a building in a scale of 1 is to 100 or 1 is to 1000. That way I can represent this building in a small paper without losing its shape because I made it with a scale. So if the building is 100 meters height, I can make it with 100 millimeter here. Still the building is looks the same, only it's a miniature small building in a paper, but in the actual case that's a big one. So that we call it as a scale. Do you understand? Later we will discuss it in details. Now you see here, this is the shape just now we have seen. So the length is 38. From here it is 19. And what about these two? What is this? What is this? What is this? And what do you mean by this? Okay. So now R means very simple. R is means radius. Okay. This means diameter. So diameter is something related to circle. Radius is related to a curve. You know the difference, right? This is simply a curve, not a complete circle. So if you are using a complete circle, it's going to be a diameter. If it's not a circle, part of a circle means you are using a radius. You understand? Later we will see. Today is just an introduction class, so don't worry. I'm sure most of you must feel like, oh my God, how I am going to draw? I'm going to be killed. No, no, don't worry. Okay? I am giving you some idea now. Don't worry at all. So, what I did here, engineering drawings are made up of graphic language and word language. The graphic language describes the shape, where the word language describes the size, location, and specification of the object. There are two languages are there. One is the graphical language, another one is the word language. The red shows the, what do you call it? The graphical language, red, and blue shows the word language. This is what engineering drawing is about. Any questions? Okay. Now I'm sure you will feel. Uh, okay. Let's see what we can show you. This is very nice, guys. You feel very uh, boring or what? I'm sure it's boring, but that is how it works. Okay. Don't worry. We'll see. Let me show you before what is a drafter so that you will have some idea. And of course, we will go to the YouTube and see uh, what is there. Okay, this is the traditional drawing tool. And remember, you are not going to buy this big. All right, you are going to buy a mini, a smaller one. So now we'll see what is the mini drafter. So let me see what we can do here. There we go, slides, and then let me see. Okay, let's go to the. All right, let me go to the what do you call it, the YouTube, and check the drafting method so that you will have some idea, because some of you are asking me what is this drafter and this. So I am sharing my screen now. Okay, in the share, can you see it? Okay, can you see my okay, right. So can you see my my okay. Now what I'm going to do, I put it in the YouTube, how to use drafter in engineering drawing. How to use the drafter in engineering drawing. In the YouTube, I just click it. and then I will go through there. There are so many videos, as you see there, how to measure the angle drafter, drafting tools, speed drafting, introduction to technical drawing, drafting tools, and see something like this. I will show you, which is very similar. Maybe you can check it in Arabic, so you will understand much better. Okay, you can find some YouTube videos which will explain to you in Arabic. So see, this is the drafting instruments. Let me show you how we can use it. Okay, these are the mini drafter. Yeah, see this one. Okay, can you see this? This is what those days I have used. Engineering drawings, how to make tools for drafting, isometric view, drawing pencils, line types. See, there are so many. In fact, there are millions of uh, these engineering videos available. So you can check it. Let me see which one is good. Okay, this one is okay. Now can you see this drafting board and third angle? Let me see. Mini drafter, engineering drawing, engineering graphics. See here, they are giving you all these the tools, some of the tools, lecturing in engineering, manual drafting. I will see the so these are the pencils. There are several drafting tables, sketching up. Let me see what's there's on drafting tools. So let me show you engineering drawing basic. Okay, so if you see there now, okay, this is a problem. Okay, now you see there, they will give you a very clear cut idea how to use a drafter and how to make the get the use of. So you have to buy these instruments. When you see there, uh, see this is so how they're using the paper and how they. This might give you an idea. Maybe well, let's go back. Let's at least give you an idea. Well, let's see. Any other basic manual drafting equally spaced parallel? How to draw face? How to use proper scale AutoCAD? How to set drafter? Drafting tools. Yeah, here drafting tools. Learning how to use French curves. Lettering guide. Technical drawing. See here. This is a very because I never used this. So, but you have to you find a way to learn it before for the next class. So it's a lot easier if you see some videos before you come over here. Okay, that will give you an idea how to use a drafter. Now you see he's showing how to use the drafter, but these kind of drafters not available in Saudi Arabia. We are using a different drafter. So you can see you put you drafter how to use drafter in Saudi Arabia, or uh, you can check it up like drafters in Saudi Arabia. Just check drafters available. Saudi Arabia, Amazon is there. Amazon is there. Drafting methods, drafting tools. Okay, so drafting tools, mechanical drafter. So uh, mini drafter uh, available in Jareer. Mini drafter also you can put it. Maybe see this. These are some of the drafters. How to use many drafters. Uh, no, this is not the one we are using here. So, because each country has their own. So if you check with the Zarir, what I do, maybe we'll check it in the internet. Let me show you. Um, Drafter for um, drawing, and you see there are many drafters in Saudi Arabia. You can put in Saudi. So here you see there are plenty of this thing. Yeah, this is what we have, and this another one. Fabric Kessler. This is what we have. Okay, and I'll show you how. Okay. This is SR 455, too very expensive. So don't buy too expensive one. Uh, it's what something like this. It's very expensive. Don't buy this. These are professional one. Let's say Jury mechanical drafter. Okay, right. Drafter uh, for sale, right? Price. Engineering, drawing, prices, Saudi Arabia. Okay, now there are plenty of this thing available. You don't need to buy this, please. Yeah, don't buy a professional one. Just go there, tell them you are studying in University Jeddah. You need the smallest one, the table one. Okay, it's there. AutoCAD SR862. No, these are too heavy. So don't buy this. Okay. Let me see which one you have. Zarir. Last time the students bought it from Zarir. If I was in university, I will show you how. But here there's no way. You can check with Zarir, okay, or any other shops you can find. All right. So let me show in Zarir. Maybe you can try in Zarir. All right. After prices, Zarir. There it is. Okay. I think drafting boards accessories. Yeah, there are so many. T square 100. So you can see that engineering. Yeah, these are some of the instruments you can see for drafting, but we need a mini drafter rather. Not only this, you can see engineering supplies online, uh, mini drafter or mini drafter available in the real drafting boards. Yeah, protractor. So not this big, okay, a small one, table one. Yeah, this probably like this, okay. But it is 455. It says this Faber Castle very expensive. You can buy a small one, but this should be something similar to this. Okay, it comes with a bag, and yeah, this is the one. Do you understand? So this is how it works. Okay, there's a whiteboard, and then there are two movable scales, so you can draw rectangle lines, and then you can put the like in the YouTube we have seen, you can use it. Okay, please check it in the internet and try to buy it. Okay, all of you, as soon as possible, because without drafter you cannot score marks. So maybe the next week also I will try to teach you some theory like what we are discussing now, but definitely after 2 weeks time we need a drafter. Do you understand, all of you, please? So this is how you check it up on the internet and buy it online, or you go there and directly buy it from them. Okay, that will be a lot easier. See, this is how they are making it. You can check it out how they make drawings there. Okay. All right. So let me go back and stop sharing. All right. Now let me see sharing files where I was. Okay. All right. All right. So we were here. Yeah, guys, you have some idea about the drafter now. You can check it. You can buy it, right? Hopefully. Yeah. Okay. So the time is 6:50 now. Uh, so let's try to learn at least a single technique today. Then we will call it a day. Okay. Because otherwise the subject is very vast. So, do we need a special kind of paper? No, no, no. You tell them in the Jarir you need A3 sheet for. They will give you everything. If you go and tell that you are from University of Jeddah, and we need an engineering drawing subject you have, and you need the instruments for drafting, and the drafter and the paper. They will ask you what paper. You say A3 and A4. A4, are everywhere we are using it. A3 is a big paper, okay, size a rectangular paper, which is when you buy the drafter, they will ask you whether you need a paper or not. Okay, buy from them. A4 also you need, but it's A3. Okay, so all you have to do is to uh, okay, yeah, it's going to be A3 paper. Okay, just tell them A3, right? That is very important. Okay, that's all right. Okay, so I know now. I will take another half an hour. Then I will leave you a little early. Don't worry. Okay. I know it's the first class, and I don't want to disturb you too much. 29 people now. There are two people now joining. Oh my God, you are losing the attendance. But anyway, send me the numbers. Okay. Today I will accept you, but not the next class. Today is okay. So the line graphics, the line types are, these are the lines, and then you have the projection method, front view, top view, side view, and geometry is three-dimensional view. So all these together is graphics, and the other one is words. Okay. Now, what are the projection methods? Uh, Now you'll find it. So just see, this is something parallel, orthogonal, multi-view, axonometric, oblique. So perspective view, parallel view. There are two views. Uh, right now, don't worry about this. Let me give you an example. Then you will learn. Let's skip this, and then we'll go there. Here, you see there. All right. So now, if you can see a component here, the same component, you imagine yourself and you are watching it exactly with a view such that your eyes and the line of sight are parallel. Do you understand? I repeat again, the parallel projection is whenever you make a view, either it's a front view, top view, side view, any view, where your eyes and the line of the sight are parallel, then that's a parallel projection. If not, it's a perspective projection. Right now, don't worry about the names of this because you are not going to memorize what is parallel, what is perspective. But you have to learn how you can project it. When you project parallel, this is exactly the same how you see. Whereas in a perspective view, it is not. This can go keep on increasing, correct? So a perspective view cannot be very similar to what you have seen, whereas parallel is more or less similar. So this is what you can see. The line of sight is an imaginary ray of light between an observer's eyes to the object. So two types of line of sight. One is parallel, another one is converging. Okay. So now you go back to this. This is what decides the type of projection. Okay, whether it is perspective or parallel. Perspective means the line of sight converges. If it goes like that, it converges. Whereas parallel is exactly the same parallel, like what we have seen now. Correct? So this is what? This is parallel, whereas this is, if this is so, this is perspective. Okay? So why we say perspective and how you see it, that is how you look at it. Whereas parallel will be always a very almost similar to this one. So when you see the parallel, so this is the two basic views, perspective and parallel. Then among the parallel, there are two different uh, projection method. One is oblique, other is orthographic. So mostly we are using orthographic. Now you see what is an orthographic uh, view. Okay, now you see here. When you make a parallel projection, that means your line of sight is parallel to your eyes. So the shape matches exactly a projection of the surface you see, or in other ways, the projection of the lines or edges you see when the eyes of an engineer and the line of sight are parallel. Whereas in the perspective projection, since there is a convergence, so the actual size will not be the same, but the shape is, of course, similar to that. Only there's a scale difference. Do you understand what I'm saying here? This is how we are making scales such that big buildings or big parts can be made with a perspective projection. Still, you can see the shape, but it's not with the scale. Do you understand? Yes, 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 yes. For the perspective projection, it not necessarily the shape must be the same, but the size may not be. So there will be some scale or something like. Whereas in parallel, it must be the same. Good. That was a very good question. Okay, you understand? People, are you very? Most of you are worried now. You're not going to pass this. Don't worry. These are very fundamental. So don't worry. Okay. All you have to know is, okay, I'm watching this shape. So I want to see. I want to draw whatever I see. So when I see it from here, I see this surface, right? Then I draw this surface. Very simple. And when I see from here, what I see, I can see this surface, right? Yeah. So I will. When I see from the top, I will draw only a rectangle, this rectangle, and there is one more. So this will be like right. That's it. Correct or not? This I cannot see because I see it parallel. Do you understand what I'm saying? When I see parallel, this surface I cannot see it from the top when I see it, but I can see this surface. I can see this surface not with the full scale, but maybe a smaller one, because when I see it from the top, it will not show me as a inclination. It simply show me a, a rectangle or a small rectangle. So that's what it is. So right now, don't worry. We are trying to learn how to project the surfaces or the edges here. There are two ways. One is parallel, other is perspective. Now, the disadvantage of perspective projection is, like one of your friends asked just now, it's not, because it's not only difficult to create, It does not reveal the exact shape and size. This is what your friend is just now saying. This is a perspective view. When you see from here, the road looks 100 meters, but here there is no width. So you will be wondering, if I take the bus cannot go further because it is closed. But is that real? No, because your eyes are watching with the perspective view. So that's why you got this, but it's not the actual one. So that is the difference, big disadvantage for the perspective projection. Do you understand what I'm saying here? So a parallel projection is normally used by engineers, whereas the perspective projection will not. Okay, just this guy has a problem. He said no. Okay, let me show you again. See, this is a parallel projection, right? I can see from here. So this is the component. So when I see from here, I can see the surface, correct or not? So this is okay. No prayer time. We have to finish it. So go for prayer maybe. So yeah, you go for prayer and come back by maybe 7:10. Right? 10 minutes or how much you need for prayer, all of you? 15 minutes. Okay, go for prayer and come back after 15 minutes. Fine. All right, guys, please go for prayer and come back. Perspective and parallel projection, which is very easier if you follow the eyes. Suppose if you take the any object and bring it to your eyes, if you cannot see it, keep it very close, then all you can see is not the full size of the object. So once you push this object a little further, then you can see the whole object. That means our human eye actually converge the object. There's always an angle that human eyes can see it. Let me show you how it can, because this is very important for you to. Okay, let me show you the one. Okay, now please watch out. Uh, Now you see there. Okay, uh, this is a big building, correct? So if the big building is a very huge building, if you go and stand somewhere here, can you see the entire building? Obviously, you cannot, because your eyes cannot see the whole building. So in order to see this building, what you have to do, you have to move a little further. Okay, now you see there. Now you see this same building. You see the window is here smaller, I mean bigger, whereas these windows are very smaller. So it's not the building's problem, it's our eyes, how it sees it. Do you understand what I'm trying to say here? So in order to see the full building, you have to move farther, and then you see the full complete building then. So this is what we can say, the perspective projection. Now you see there. Now you keep it at a parallel, and yeah, now you see here. This building is very big, but as it goes there, it's going smaller and smaller, and on the farther end, it is much smaller. It is how your eye looks it, but it's not actual. Have you seen that? So this is the same size, but this is our eye which see this, so it converges to a smaller one. So this is the problem with what you have seen, because our eyes have its own what do you call it, ability to see those. So the same thing we are applying in drawing. Okay, now you see there. This is, now you see that this is our human eye. In the human eye, if you keep an object too closer, it cannot see it fully. So you have to pull it a little farther so that you can see the full, complete. Yeah, now you see that. This is a human eye, so you can see the edges. But if it comes closer, you may not see these edges. All you can see is somewhere, and the human eye try to converge it, and that is what we have shown in the drawing. And perhaps this is not a correct one because the size is not the same as you see it. Now you see, if this is a little farther, of course your eyes can see that. So this is the problem with the. So this is what I said. The view just now you mentioned. Okay. All right. Now, if we take the, let's say this is too big. So, yeah, this is what the perspective view. When you see it from here, this looks smaller, and this one looks bigger. It depends on the particular view where you see it. If you keep your eye very close, then you can see only this portion. So this is not a complete size or shape. You can see it. This is exactly what we have said just now. Is a perspective view. Suppose if it is parallel, now you see this is the parallel view. So this your eyes and the edges are the same. So if you project it, you can find it the exact size and shape. So this is the parallel view. The other one is the perspective view. Okay, I hope you understand this. So now you see there, this section you can see directly, and this small section will be come somewhere here. Okay, now you see that. All right. So this is the parallel view. As you can see that this edges, these four edges you can see of course, and these four edges you can see it. So this is how an engineering section or engineering view can be parallel so that you won't miss the size and shape of it. So now you see how we can see a component here. So just put from there and watch it from, okay, now you see there. So now if you consider this, this is the front view when you see it. So this is the front view, and see it from the parallel. Then how you just project a light here, then put the lights, so the light will show the shadow just behind it. Just you see there. Now you see there. Now you see, put a light here. So when you see you put a light, so this will be projected there. This is exactly the same size of this particular surface. So this is the parallel view. Now you see there, if you draw the parallel line, this surface exactly shows this. Now see, this is our front view now. So by using parallel view, this is the front view where you see it from here. Okay. So if you put this here, and that is how we draw in an engineering drawing. Okay. Hopefully. I hope you understand the difference between the what do you call it, the perspective view and the parallel view. All right. All right. So let's see. The slides. Where is the slide? Okay, share files. Okay. Now where we are. Now we are here, and then So hopefully we'll see from where we stopped here. So the perspective view and parallel view is how you look at it. Now you see here. So this is what now we have seen. Put a light and make it parallel, then you can see the surface here. Whereas in the perspective view, you won't see because this your eyes how it sees it. If your eyes are too closer, it looks a small portion. So you have to push this object a little farther so you can see it. So that means the actual size and what you have seen is not the same. That is a perspective projection, and this projection is not being used very much used in engineering, and we are using only the parallel projection. So this is very similar. Now what we have seen, a long, narrow road will be looking like this, and this is not the actual case when you see it. Although your eyes will watch like this only because our eyes has its own uh, the length of vision, right? So orthographic projection is just to project it the parallel projection technique, and this projection plane will be perpendicular to the projection plane. So suppose if we draw the same parallel projection technique and the parallel lines are perpendicular to the projection plane. Suppose what it means, suppose I am watching it from here, and then this is the surface I could see, correct or not? Right? So this is the parallel lines, the line of sight from my eyes, and this is the projected surface. So if this is right angle or perpendicular, then whatever you see, that is the orthographic projection. So don't worry about it now. Forget about orthographic and whatever it is. Very simple thing is you see it from this side, and your eyes and these lines of your line of eyes, a line of sight, and the edges are parallel, such that you are projecting it with a line perpendicular to the surface. So it is something like you put a light on it. So the light, whatever you see parallel to this, that you draw it, and that is what we call an orthographic projection. Okay, so this is the projected plane, the green color one, and these are the projected lines, and this is the actual plane. So here it is 90 degree, so that's why they say it is perpendicular to the projected plane. Now you see there, these are 90. This is what an orthographic projection. So whatever I see from here, this projection plan, this is shows the actual size and shape of the component. Okay, that we call it as orthographic projection. And remember, you don't need to memorize all these things now. No need at all. So if I give you a component like this, I will ask you what is the orthographic projection from this front view. Then you imagine yourself parallel, keep your eyes parallel to this, so this line. So whatever you see when it is parallel, just project it and draw it. That is how you get 5 marks. That's it. The point here is what you have to do, draw the line, and whatever you see it, that you have to draw. Suppose if this is the front view, then what, how can I draw it? Okay, I can draw like this, correct or not? It's like this, correct? So this is the front view, this is the top view. When I see it from the top view, this will be like that. So this is what you are going to draw in your in your uh, exercises. All right. Okay. So we will stop for another 10 minutes. We will stop it. So don't worry. Now orthographic view, if you see, depends on the relative position of the objective. Now you see from here, this surface you project it here. But if you just rotate this object to like this, then you will see one rectangle here. That is this rectangle, and another rectangle here. Can you see this? Do you understand? Guys, you understand what I'm saying here? If the surface is perpendicular to the projected plane, then you can see exactly the same. But if you rotate it, you will see there are two surfaces, not in the same, but it will be in a different, and like this also. So we call it as the multi-view drawing. Now you see this, more than one view is required to represent the object, then that's a multi-view drawing. So orthographic view is on the relative position of the object to the line of the sight. Then three dimension also, if you use it, then that's axonometric. So there are several types of views. One is parallel, then perspective, and then it's parallel. You have orthographic, then multi-view, and axonometric. So this is what we have seen in the previous slide here. Okay, projection method, perspective, and parallel. In the parallel, you have orthographic, and orthographic you have axonometric and multi-view. So we have seen all these three now. Do you understand? So how do you see parallel? Then from the parallel, how you see with orthographic? Okay. So no, your class is until 7:50. So maybe you have to, when this class must be usually until 7:50. So not like this. Maybe you have to be prepared. I know this is little difficult for you, but the subject is too very huge. So be patient enough so that we will finish this. That no one will fail this class. That is my idea. That not a single student of this class should fail in this. Okay. All right. So this is the last slide. Don't worry. Uh, we will close it by 7, maybe another 5, 7:40, shall we? Before 10 minutes you can go. Okay, just one or two slides, that's it. At least you have an idea before next week. I mean, if you come by next class, you have an idea. Okay, now axonometric or isometric drawing is, you can see it from a third angle projection, so that you can see the whole, you can make it a distorted isometric drawing. So here it is easy to understand, but of course the size and shape will be different. You know why? If you see it parallelly, this is a circle, correct or not? But when you see it with the isometric drawing, it's not parallel, it becomes a ellipse. That's why an isometric drawing will give you an idea, but it's not exactly show the actual shape. Do you understand what I'm saying here? If you see it with the parallel, now if you see from here, you can see the exact round. But when you see as a whole in three-dimensional view, this is not the circle, it is like some elliptical one. So that is the difference between an isometric drawing, or you can say 3D to 2D, very simple. When you see in the 3D and 2D, this is the only difference. Okay. All right. So this is the last slide. We are not going to go. Yeah, introduction. We will finish it now. That's it. Okay. We'll stop here. So now, multi-view drawing. This is the three-dimensional, or you can say the isometric view. Correct or not? This is the isometric view, and these two are the projected views by using the parallel projection. So when I see it from this front view, all I can see is this surface, which is this surface, correct? Then I cannot see this surface because this is parallel to my eyesight. So only I could see this surface, correct? So this is this surface, and I cannot see this surface also because this is parallel to my eyes. This also I cannot see it because this is parallel to my eyes. So all I can see it, if you put a light, the light can reflect only this section and this portion. So that is what you have seen from here. This is the front view. This is front view. No, not. And from the next class, I will record it. Today is just, it's very simple. Next class, we will record it, okay? From next class onwards, we will record it. Because I thought today is just an introduction class. So we are not covered much, so it's okay. I will repeat it next class, don't worry. So if this is the front view, then this would be the side view here. So in the side view, if you see, I can see this surface, right? So that is this surface, correct or not? But I cannot see the circle. This circle I can see it from the front, but not from the side, correct or not? So this is although there, but it is hidden, so we make it as a dotted line. All right. So I am using multiple views to explain one particular component. The whole component can be shown as a or you can say an isometric view or multi-view. The other one is used to show the actual size and shape of it. So by doing this, what you are trying to convey, you are trying to convey the shape of your design. That's the idea. Now you communicate your idea to anyone, any engineer, by using these views or by using these drawings. Okay. So thank you very much for your patience today. I am very happy that so many people attended today. So those who came late, just put your numbers in the chat. I will give you attendance today, but next class you should not come late. And remember, today also, as far as the blackboard is concerned, as far as the University of Jeddah is concerned, you two are absent. Okay, you two are absent. Officially, you are absent, but personally to me you are not. So I am giving you my attendance, but officially you are absent because this is blackboard how it works. So next class onwards, don't come after 10 minutes, then you will be automatically absent. Okay. Okay, thank you very much. We'll call it a day. Have a nice good night. Thank you very much. We'll meet on the same time next week, same place. Thank you very much. Bye.